Okay, thank you, Greg. So we're going to look at the atmosphere side of things, which of course generated a lot of the flooding that we saw in the pictures coming up. So here's a nice picture of Ivan, one of the instigators of the problems in September 2004. So this is the outline that we're going to follow, and we're really going to kind of take a large picture view and then move into what happened literally in our backyard here in Asheville. So let's first take a look at some historical tracks. This was a study done by colleagues at the National Weather Service office in Blacksburg, Virginia. This study came out in 2005, and we're going to focus on the tracks primarily of those systems that come through the Gulf Coast. And so they binned the different tracks into 4 different categories, and some of these would not do much here in the southern Appalachians in the Asheville region, and one of those is if the track would go west of the mountains, generally we would not expect to see many impacts here, fairly minimal impacts. The other category, across the mountains from the west, those would have a significant impact in the central Appalachians, but still the track is less than favorable for us seeing much precipitation here in the southern Appalachians. And then the other track is east of our area, and again, these kinds of tracks would kind of encourage flow down the mountains, and if you follow the weather forecast, anytime you have downslope flow, that's usually not good at all for getting much, if any, precipitation whatsoever. So the final category of the Gulf Coast landfalling systems are what they call along the Appalachian spine, and if you look closely, you can see that Francis and Ivan are represented here. But then you can also see when were some of the other significant storms of note and when did they happen. And it's just not all that common that you see a tropical cyclone track along the spine of the Appalachians. So generally, for us here in the western North Carolina region to have a problem, it's usually easier if our tropical systems are making landfall along the Florida coast and generally through the Gulf Coast region. The exception, of course, though, Hugo 1989, some of you probably experienced that. That one made a beeline right from the South Carolina coast right over Charleston into western North Carolina. But again, that's a fairly rare kind of track, at least recently. Now let's talk about 2004 and the season overall. First, we're going to focus in on the month of September. And the left-hand panel is basically a map of the steering currents in the middle troposphere. And so this is the 30-year climatology ending in 2010. And if I superimpose, these are the kinds of winds you'd expect somewhat strong westerlies along the southeastern region. And that's corresponding to a fairly broad trough at this steering level in a climatological sense. Now, if we look at the far right panel, this is the departure from what would be considered climatology, or the departure from normal. And what we see highlighted in the northeastern part of the country is a significant ridging that was in place, and you can kind of see it in the little hump here in the height contours over the east coast. And what that does then is it provides what we call an easterly anomaly in the winds. Well, in everyday terms, if we look at the middle panel, all that means is that the westerlies that we typically see at this steering level were much weaker during the month of September 2004 than normal. What does that mean? Well, for our tropical systems that are starting to curve northward, they are encountering weaker westerly winds, which allows them to track a little bit further west than they normally might. And so the consequence of that is a storm track, that map that looks like this. Notice all of the tropical systems that were able to make their way into the Gulf. And if you are a fan of visiting Florida, 2004 was a terrible season for someone to be living in Florida. 5 different systems impacted Florida directly. And usually if Florida is going to get hit, chances that we're going to experience something are pretty good. And so this is the entire list of systems that occurred back in 2004. And again, notice that the Gulf Coast has quite a few storms transiting across it. So when we look at 2004, a lot of Floridians wanted to change their state motto to the plywood state because they had to put plywood up so often, especially during the month of September. $45 billion of damage to the United States, 15 named storms, 9 hurricanes, 6 major. And you can see the numbers that compare to that in terms of average. Ivan was a major hurricane, that's Cat 3 or greater, for 10 days. That set a record. That's very unusual. Some of the conditions leading to this active season, the sea surface temperatures in the subtropics were quite warm, 3rd warmest on record as of that time. As I just mentioned, the steering level westerlies were weak, so that allowed more of the storms to track into the Gulf of Mexico. And also, another ingredient that you look for is vertical wind shear. And the vertical wind shear in this hurricane season was relatively weak, so that allows convection to organize itself and become a tropical storm and a hurricane. So now let's look at the individual big name storms, the ones that really brought a lot of water into our region. So the first track here is of Storm Francis, basically from the 25th of August all the way through the 8th of September, and I would even argue that the remnants go all the way through 10th of September into the northeast. So notice tracks a little bit north of Cuba and hits the poor people of Florida. They've already had experienced Charlie earlier in the season. So here's a satellite loop. We see Francis making landfall. This is an IR, so we're looking at the cold clouds at the top of the storm, and rumbling right in her wake is Ivan. Notice the track of Ivan is a little bit further south compared to what Francis went through. Now we're going to focus on a radar loop. So this is kind of showing us where the intense rainfall is occurring as Francis is making her way up into the southeast from the night of September 5th all the way to the night of September 8th. And notice the broad area of reflectivity in central and western North Carolina. So a very favorable track for getting a lot of precipitation here in western North Carolina. We're going to look at a parameter that is called precipitable water. And basically, if you take all of the water vapor that's in the atmosphere and convert it to rain, the amount of rain that you would measure after making that conversion is basically what precipitable water is all about. So you can think of it as the potential to create rain. So the higher the value, the more rain you might expect if you have enough of a dynamical system to convert the water vapor to rain. And here's a climatology done by colleagues at the Weather Service way up in South Dakota. But they took sounding data for a long period of time. This one is from Greensboro, North Carolina, and they looked at precipitable water. What's climatology? And the median for Greensboro weather soundings is somewhere about just under 1.25 inches of rain if we rained out all the water vapor. But that's not a mountain area. Let's look at Roanoke, Virginia, which is a mountain location. And their median is about just under 1 inch. So that's, somewhere Asheville is probably in the middle, in between the two locations. So we can think of our precipitable water for the month of September as being the median value somewhere around 1.1 inches. So keep that number in mind now, because we're going to march through a series of maps that show us in shading precipitable water on this color scale. We're also looking at winds right at mountaintop level. And we're also tracking in the contours the isobars, or basically the pressure that's tracking Francis in this example. So notice at the 8 o'clock in the morning on the 6th of September, our precipitable water values are somewhere not quite, but almost 1.5 inches. Notice the winds are blowing pretty much normal to the average ridgeline of the southern Appalachians. If you want to get the most bang for your buck, you want humid air being directed right towards that ridgeline. So you want a southeasterly fetch or southeasterly wind direction to get a maximum conversion of that water vapor into precipitation. Well, where did the air parcels come from that arrive at Asheville, which is highlighted here in this plus sign? Where did it come from over the past 3 days at 8 o'clock in the morning on the 6th of September? Well, we have at 3 different levels. Basically at the middle and lower part of the cloud that's making precipitation. So corresponding to almost 10,000 feet, 5,000 feet in blue, and 1,600 feet in red. Where did all these air parcels come from to converge at 8 o'clock in the morning? Well, it's not hard to see. They all came from over the Atlantic Ocean. And remember, this time of year, the sea surface temperatures were much warmer than normal, and so that's bringing in a lot of humidity to converge over Asheville. Let's talk about 24 hours later, 8 o'clock in the morning on the 7th. Now our precipitable water value has increased here at Asheville. We're up to over 1.8 inches. And again, all of our air parcels that arrived in Asheville at that time came from over warm water. We moved to 24 hours later. This is the peak of the precipitable water at about 8 o'clock in the morning on the 8th of September. It's really up to 2 inches. Remember, our median is about 1.1. And then at this time now, a lot of our air parcels are caught in the circulation of Francis, the low-level air parcels coming in from over the warm Atlantic Gulf Stream current. And then finally, at 8 o'clock in the morning on the 9th of September, our storm Francis is tracked far enough so that now we've got our winds changing over from southeast to a northwest flow. So now we've got downslope flow. This is the situation now where we're not going to expect much, if any, precipitation at this time. And the air parcels correspond to now coming from, at least at low levels, from a drier regime. So let's take a look. Where does 2 inches fall? Well, if we compare it to Greensboro and Roanoke, 2 inches associated with Francis is 2 standard deviations above the mean. That is a significant amount of water vapor and over a fairly long period of time. Here's a rainfall map from our colleagues at the Raleigh office. And if you look at the area covered by the blue, it's a pretty substantial area of 4 inches or greater, highlighted by the blue in central and western North Carolina. If we look at the map created by our colleagues at the Greer, South Carolina office, the purple-pink shading is in amounts exceeding, or storm total amounts exceeding 10 inches. That is a large stripe of precipitation exceeding 10 inches. Asheville Airport only reported 2.8. Our colleague Grant Googe measured 6.7 in the I-40 corridor, just not far from Black Mountain. And then the high total, the record amount recorded for the entire eastern seaboard happened in Linville Falls, over 18 inches of rain. Just what I want to highlight with this meteogram, this is a measurement at the Asheville Airport, focusing just kind of on the winds and the pressure trend. Not a whole lot. The precipitation actually started late at night on the 6th and pretty much made it all the way through September 7th. Winds aren't a whole lot in terms of speed. You see some gusting getting to 15 or 18 knots. Here's the pressure minimum associated with Francis passing close by. Precipitation continuing overnight and then finally ending kind of in the late morning, early afternoon on the 8th of September. So we had a very long period of cross-mountain flow bringing very humid air up the mountains, and that's going to create a bunch of rain. So heavy precipitation, as we saw, was the hallmark of Francis. Let's take a quick look at Ivan. Ivan tracked, as I said, further south of Cuba. And there's Ivan there, and of course Gene following on Ivan's heels. I'm not going to talk about Gene in the presentation this morning. We're going to focus on Ivan here. And there's the radar image. Ivan took a slightly different track, followed almost exactly the North Carolina-Tennessee border as its track. So it did not have as much coverage with its rainfall shield across western and central North Carolina as did Francis. But Ivan had some other things happen that Francis did not. So the overall precipitable water amounts for Ivan were not as impressive as for Francis. Here we're just above 1.8. and it probably maxes out somewhere about 1.8 compared to 2 for Francis. Again, our air parcels are still all coming off the Atlantic, and by within 48 hours, the winds had shifted to being across the mountains from the northwest, dry conditions, and not as much precipitation at that point. Again, looking at the area of blue, light blue, that's 4 inches or greater accumulation for the storm, doesn't cover quite as much. It's highlighted primarily isolated really in the western mountains. And then you look at areas of 10 inches or greater, and it's very spotty, not as widespread coverage and heavy precipitation. Asheville Airport, we don't know what happened because there was a power outage. Downtown reported 3.66 inches associated with Ivan, and the maximum observation for the entire eastern seaboard was down southwest of us in Transylvania County, Crusoe. So the thing I want to highlight with this track of what Ivan did at the Asheville Airport is on the late night hours of the 16th moving to the early morning hours of the 17th. If we look down here in the basically overnight on the 16th going to the 17th, we have winds that are much stronger and gusts up to 35 knots, which is about 40 miles per hour. So stronger winds meant a lot of widespread power outages. So the final question, of course, is can this happen again? And of course the answer is yes. If we get some ridging occurring in the eastern part of the U.S., we get warm sea surface temperature anomalies like we saw in the September of 2004 event. And if we get another situation where we don't get much vertical wind shear, we can have this happen again. But it's not that simple. It's also what are the conditions off the west coast of Africa. And so there's a whole lot of different factors that have to happen again for us to have a repeat of September 2004. But again, it's quite likely that each of those unique anomalies that contributed to that event could certainly happen again. And that concludes my presentation.